Alright guys, just as a quick review on the material that we covered last week in class on chapters 8, 11, and 12, we covered our metrics and our dosage calculations. To start off with our metrics, those metrics we covered in chapter 8, you guys are allowed to use your all's metric chart, the chart that you guys see on your screen in front of you, and it also will be provided for you on your quiz this morning. So anytime we're converting metrics, remember that what we're doing is we're using this chart. We're using this chart as almost like a map. That this map is going to show us in representing where we're starting is our starting point on our map, so meaning the unit that we have. So such as if I have a question that says, whoops, that is not what I meant to do. If I have a question that has, say, let's say 4 kilograms, and I want to know what that is in grams. I'm using the abbreviations, but you'll see them written out on your all's quiz. So remember, we know that this is a metric question because I'm going from something that ends in the base gram and I'm converting it to something that also ends in the base gram. The difference that we're seeing here is the prefixes. So what we're starting with, we have 4 kilograms. What we're trying to do is convert it to grams. So what we're starting with is where we're going to start on our map, and we're paying attention to the prefix, not necessarily the base. So what I mean by that is we're paying attention that this is a kilogram. So kilo is where I'm starting on my map. I'm not too concerned with the 4 just yet. That's going to come in a second. So I've got 4 kilograms. So I'm starting at kilo. And since I'm trying to convert to just gram by itself, there is no prefix in front of gram. So remember that makes it one of our bases. So that's where we're trying to go on our map up there at the top. So going from kilo to base, you can tell based on what we're seeing up there above, kilo to base is 3 movements in the right direction. So I'm going to the right. And I know that because again, I'm counting from kilo to hecto is 1 movement. Hecto to deca is 2. Deca to base would be then 3 movements. So now is here where that 4 comes in. Because what that movement represents, remember, is decimal movement. So my 4 being a whole number, we know that that decimal starts there just behind the 4. 4 is the same thing as 4 with a decimal right behind it. But my map told me to take that decimal and move it 1, 2, 3 places to the right. I've got empty spaces here. If my decimal is going to end up down here, I have to have something in those empty spaces, so we fill them with zeros. So that means 4 kilograms is the same thing as 4,000 grams. So that's just one example. On the other hand, if we do another one, let me see here if I can just erase this real quickly. Let's see. There we go. Let's say we have this time... get this erased real quick. This time we have, let's say, 700 milligrams, and I want to convert that to grams. So I'm using grams because it's the most common thing you'll see, especially in healthcare with medications and such. But in this case, I'm going from milligrams to grams. So you can see based on that chart, milli, I'm starting at the prefix milli, so I'm starting right here on my map per se. And then I'm trying to go to gram again, which is just my base because there's no prefix in front of it. So in this particular occasion, going from milli to base would be 3 places, but this time to the left. So that's what I'm going to do with my decimal. 700 again is a whole number. So we start with that decimal just right behind the 0. But my map told me to take it 3 places to the left. So 1 would put it between our zeros. 2 in front of the first 0. 3 movements would put it in front of the 7. Making my answer 0.7. Or just 0.7 would be fine too. If you don't put that 0 in front, that's okay. Just make sure I can always clearly see your decimal if there's supposed to be a decimal in the answer. Okay. So let me get this out of the way. No, I want that here. There we go. Okay, so another example too. Let's not forget why those X's need to be there on my chart. Those X's represent movements. So if I had given another example, let's say instead of 700 milligrams, let's say we have 700 micrograms, and I want to convert that to grams. So still converting to grams. We won't always convert to grams, but this so happens to be the examples that I'm using here. But for micro is all the way down here, that particular prefix, all the way down here on the far right of my map up there. And I'm trying to convert to gram again, because it has no prefix. I'm at my base. This time, if you count your movements, remember those X's also serve as movements. There are no units to represent those particular place values. Remember, if we go back to when we talked about our place values, deci was 1/10, centi was 1/100th, milli was 1/1000th. The first X represents the 1/10,000th, the second X represents the 1/100,000th, and micro represents 1/1,000,000th. There just so happens to not be any prefixes that represent those two particular place values, so we just use X's. But we cannot leave them out if we're using this map to represent decimal movement. So micro to base, to count that movement, micro to the first X is 1, to the second X is 2, then to milli would be 3, centi is 4, deci is 5. To make it all the way to our base, we would have to go 6 places to the left. So, again, 700 is a whole number, so our decimal starts back here, but my map now wants me to take it 6 places to the left. So 1, 2, 3 puts it in front of the 7, but 4, 5, 6 is going to end up adding a couple zeros. My answer here should be 0.0007. Okay, so that would be my answer in this case. Remember that we would get the same answer if we had, remember the bases don't really have a whole lot of significance here, that the bases are simply just what we're measuring. Grams measures a weight, liters measures a liquid, whereas meters measures a distance. So had that question have said 700 microliters, and I was trying to convert that to liters, I would actually get the exact same answer, 0.007, because it's still the same movement. Micro is down here, liter doesn't have a prefix on it, so it's one of my bases. So it would still be 6 places to the left. So don't get those confused when you see liters instead of grams. Again, your bases aren't as significant. We're paying attention to the prefixes. Always make sure we're paying attention to those prefixes. So I hope that helps you with your refresher for our metrics. Again, like I said, your chart should be on your test there for you. So you don't need to worry about having to memorize this chart at all. It'll be on the test. The next thing we looked at last week, we looked at our dosage calculations. Dosage calculations, we remember we followed this particular formula, D divided by H times Q. Now, this formula is not on your test for you. However, I told you guys last week that you're welcome to use the charts that you were handed in Unit 4. Those particular charts just need to be blank. I know that for the final, we're able to cover our charts with notes, but I need you to just have a blank chart today. And that particular formula is on that chart. You don't need any of those conversions for any reason today. However, if you do feel like you need that formula in front of you, you're welcome to use your conversion chart. It is back there. But quite a simple formula. If you have just D over H times Q, you shouldn't have any problem with these questions. D, again, remember, it represents the doctor's order or the dosage ordered. It's the dosage strength that's been ordered. So you're going to see grams, milligrams, what have you measured here, or representing that measurement here. H, also a dosage, however, this is the dosage that we have, so how that medicine comes. And then Q is the quantity for how that medicine comes. So these questions will be given as such. You'll have, an ordered dose. So say what was ordered is, let's say, 50 milligrams of a particular drug. And then you'll also be given what we have. So this represents how that medicine comes. If we have a particular medicine that's, say, 10 milligrams per tablet, I'll just write per tab here, then it's going to ask us, okay, well then what do we give the patient? Well, what was ordered is 50 milligrams. That's what this patient needs to take. But that medication comes in 10 milligrams per each tablet. So in your head, you may be thinking, okay, that's an easy 5 tablets. Yes, remember, some of these are easy to do in your head, and you're welcome to do them in your head. You do not have to show me all your work on this. But if you were to fill that out according to our D over H times Q formula, doctor's order was 50 milligrams. Our H, again, the dosage that we have is, I don't know why I wrote H, the dosage that we have is 10 milligrams. And our quantity, since it's 10 milligrams per one tablet, our quantity is 1 tab. Okay, so in finishing this problem, it's just D divided by H. So in our example, 50 divided by 10, which is 5, times 1 tablet would still be 5. Don't forget, our one thing that we need to remember in our D over H times Q formula is that D and H must be the same unit, because what I want to happen is I want the unit milligrams to cancel out. I want them to be the same, so that they do that, and the numbers don't cancel out because they're not the same, so I'm still going to take 50 divided by 10 and then times 1. So therefore the only unit left over in this problem is the unit of my quantity, which is why my answer is also the same unit. That if that particular medicine comes in tablets, I need to tell that patient how many tablets to take. And that's what I want. So D and H must be the same. In an example where they're not the same, let's go ahead and take a look at one of those. Let's say we have a doctor or a physician that orders, let's say, 0.4 grams of a particular drug that comes in, let's say what we have is 100 milligrams per 2 milliliters. Another thing we want to pay attention to is that quantity, because then in this particular example, that quantity is going to change. So in filling out D over H times Q, what I have is 0.4 grams. My H is 100 milligrams, and my Q is 2 milliliters. So everything's good except D and H are not the same unit, so we need to make that happen. We need D and H to both be grams or maybe both be milligrams. And my advice to you last week was to put everything into milligrams, because typically that's what you're going to see. Most common unit you guys will see is milligrams. So if we just get in a habit of putting everything into milligrams, we should be okay on that. So what that means is our H is good. Our H is in the unit that I want it to be in, but D is not. So here's what we need to do. We need to take those grams in that doctor's order and convert it to milligrams. And that goes back to what we did in our metrics. I'm taking grams, which again is one of my bases, and I'm converting it to milli, which is in the prefix milli, which is 3 places to the right. So moving that decimal from in front of the 4, moving it 3 places to the right would make it 400. But now that, and remember, we're not changing the doctor's order at all. We're just saying, hey, 0.4 grams is the exact same thing as 400 milligrams. And since that medicine comes in milligrams, we're going to use that instead. So now I can go ahead and divide this out. 400 divided by 100 is 4. Don't forget your quantity has changed here, so we multiply it by 2. 4 times 2, this patient would have to take 8 milliliters. So that's what we need to make sure of. That's what I mean by D and H must be the same unit. In the second chapter that we use dosage calculations in chapter, let me undo this real quick. I want to just erase the example down there. There we go. In chapter 12, the only real difference that we saw is that sometimes you may get a question where the label, instead of just saying what you have is this amount of milligrams, instead you may see a ratio or a percent. So an example of that would be this. If I have a question that says, okay, physician ordered, let's say 2,000 milligrams of something. But on that label, or that vial, it's a parenteral dosage, means it's an injection. It's labeled as a, let's say, 1 to 200 solution. So what does that mean in terms of a 1 to 200 solution? Don't forget that anytime we see a ratio, always is just a shorter version of saying that I have 1 gram per 200 milliliters. It's just a shorter way so that we can put it on that little vial and condense that down. But pay attention to the fact that that means our H is going to be in grams and not in milligrams. So what that means for our D over H times Q formula in this example, doctor's order, always just given to us. So that's 2,000 milligrams. What I have is 1 gram, and my quantity is 200 milliliters here. So once again, we need to make sure that D and H get to the same unit. So that means we're going to need to change that grams to milligrams. So I change 1 gram, I need to convert it to milligrams. Grams to milligrams up on my chart again is base to milli, so that's 3 to the right. So 1 being a decimal, or 1 as a decimal is written as 1 with the decimal behind it. Moving it 3 places to the right makes it 1,000. So my H in this case is actually 1,000 milligrams. So finishing this out, this would be 2,000 divided by 1,000, which is 2, times 200 milliliters. This patient is going to receive 400 milliliters of this particular injection or IV or whatever it may be. Okay, so don't forget that when we see ratios, don't forget that a ratio, whatever it may be, the first number is always the amount of grams that I have, or in other words, the H in my D over H times Q formula, and then the second number is the amount of milliliters, or the Q, my quantity, in that D over H times Q formula. Another example would be if instead of a ratio, if instead it said that we have, let's do the same ordered dose. Let's say doctor orders 2,000 milligrams, but this time 2,000 milligrams of a 10% solution. A 10% solution. Easy way to think about this is that a 10% solution can also be written as a ratio, so we can compare it to what we just did in the previous example. 10% is also the same thing as 10 to 100. Remember, anytime we have a percent, that's the same thing as saying, again, all percents are out of 100, so that means we have 10 out of 100. But once again, all we've done is convert it to a ratio, but ratios all mean the same thing. That first number is how many grams I have in this particular medication for every 100 milliliters in this case. The second number is just 100 in this one. So in filling out D over H times Q, that means I have 2,000 milligrams. Oops, it's a weird looking M. 2,000 milligrams over 10 grams times 100 milliliters. But once again, D and H do not match. We need to make sure that they do. So I'm going to go ahead and convert my bottom number. I'll convert grams to milligrams. So remember, up on my metric chart, base to milli is 3 places to the right. So moving that 3 places to the right would change this to 10,000. Okay. And then making that, since that's 10,000, but it's now D and H are both in milligrams, so I can go ahead and finish this out. 2,000 divided by 10,000 is 0.2 times 100 of our quantity there would be 20. So this person is going to take 20 milliliters of whatever this particular drug is. So I hope that helps as you guys get ready to start your all's quiz this morning. Good luck. If you guys have any questions, feel free to ask Erica, and she can send me a quick message or something to let me know. All right, thanks, guys.